Hi, today we are going to learn about a concept called hysteresis. This comes in magnetism chapter. Okay, now what is hysteresis means? Basically, we this is a process of studying the amount of magnetization and demagnetization, how it happens. Okay, so basically in this what they do is they take a solenoid, okay, and coils are rotated around it, and some current is provided to it. You know that when moving charges are there, they create magnetic field around them, and if the material is good, they will magnetize it. So let us say that moving charges have a field B, and the extent of magnetization is H. So we have a relationship H is equal to mu naught B. Suppose this is hollow inside and only air is there. If some other medium is there, we have to take that particular medium's relative value we have to take. We have to multiply this with mu r just in case some other medium is there. So here what they do is, so we will plot a graph between, we'll plot a graph between B versus H. Remember, B is the field you are providing. B is the field you provided. Field you provided. Okay. And H is the amount of magnetization happening. That means you are giving 100 and someone is taking 80. Okay. So 100 is the limit and the amount taken by the other person is 80, like that. Okay, so H can never exceed B. H can be maximum B. So here they take a material and they pass the current first in a particular direction, and they keep on increasing the current. When they keep on increasing the current, the B value increases, and if depending upon the material type, whether it's a ferromagnetic, it will get magnetized. So it is observed that the curvature will be like this. Okay, now I have drawn a straight line here. So the meaning of this is like you're increasing current from 0, 10, 20 up to 100 you went. It will reach a saturation value. After that, if you make this 150 amps or 200 amps or whatever, it will remain same only. Okay, so that means it has the magnetization process has reached its maximum value. Then what they will do, they will demagnetize it. So while they were doing demagnetization, that is the current direction was like this, now they will apply opposite current. So initially the current direction was like this, now they will make the current direction like this, opposite. So our assumption is that it should follow the same path, like O to A it went. Normally we'll think that A to O it will come, but actually it does not come like that. It goes to some other point B. Okay, so this actually means that OB part is the retained part. So some part of it has already become permanent magnet. Okay, so initially we went in one direction current. Now we are reducing the current and we are trying to make H 0. So we went from 0 to 100, and from 100 to 0 we came back. 100 to 0 we came back, but still some amount is retained. So we could not make it 0. So further in the negative direction we will increase further more current. Okay, we will increase more current in this direction now, anti-clockwise direction. So there will come a point where it will become 0. Okay, so this is in one direction. So we want to see what is the extent of magnetization in the other direction. So similarly, the process what we have done in the positive direction, we will increase that in the negative direction. So negative direction also the same process will happen. Okay, and like what happened between 0 to, O to A and A to B, it will happen in the negative direction also. Okay, so finally, like this process is called the retentivity. So this is the retentivity. Okay, in the another direction. So here you can see that still you could not make H0. So whatever we have done in the forward direction, we will like this value what we have achieved, no? See, from 0 to 100 you went, 100 to 0 came back. So at 0 it is not becoming like H is not becoming 0. So you further went, like in the negative direction you went up to minus 200 amps, like that. Okay, so the same process what we have done in the forward process we'll do in the backward process. So finally it will come down to here, and it will the value will become 0. Okay, so this is how one complete cycle we have completed. When for the next cycle we go, it will be like this. Okay, so this is like one full cycle. In ideal condition we would have assumed that it will go like this and it will come like this, and it will go like this and it will come like this, but this did not happen. It happened like this. Okay, so hysteresis is a process of a lagging process. It's a lagging process. Why it is a lagging process means, see, like I told in this example, when you're going in the one direction, magnetization is happening. Is it following the same path? It is not following the same path. In fact, it is coming over here. So this much portion it is lagging. No? So to make it 0, you have to go for negative B value. Then only it is becoming 0. So both started at same point, but both are not returning to the same point. Both are not returning to the same point. So there is a lag. Okay, that's why hysteresis is called a lagging process. A lagging process between H and B. This area under this graph, it gives you heat loss in the process. Okay, heat loss in the process. So different objects will have different area of the curves, and this value I forgot to tell. This is called coercivity, and this value is called retentivity. Okay, so even these values are noted, and they have got different purposes actually, whether what type of iron you want to, what type of magnet you are trying to make, so they will be used accordingly. Okay, so this is about hysteresis process, and any question comes on that, you should be able to attempt that. Thank you.